Hi, everyone. Thank you so much for joining us today. We're going to give it just a moment for everyone to jump in the session, and then we'll get started. Okay, great. Hi, everyone. Thank you for joining us today. My name is Courtney Brown, and I'm a Senior Marketing Manager here at EDB. I will be your host today for our webinar, Online Upgrades Using Logical Replication. I'm joined by Florin, developer and DBA at EDB. Now, before I turn it over, I just want to go through a few housekeeping items. This presentation is being recorded. We'll be sharing the recording and the slides with all of you after the broadcast. All of your lines are currently muted. If you have a question, feel free to submit it in the question panel. Today's session is scheduled for about an hour, and we expect the presentation to take most of the time, but any extra time we've allotted for Q&A. If we are not able to address all of your questions, we'll be sure to follow up afterwards with any unanswered questions. And now I will hand it over. Thank you.
Thank you, Courtney. Hi, everyone. Is your production environment in need of a refresh? Soon your PostgreSQL will be no longer supported. In this presentation, I'll explain why you should always update and do it without significantly impacting your production. My name is Florin, and I started working at Second Quadrant 3 years ago, and now I'm part of the EDB. I am a member of the Pglogical and BDR team as a developer, tester, support engineer, and even consultant on some occasions. I also been involved in organizing PG Day in Italy and hope one day to become a PostgreSQL contributor. So what's for today's agenda? I will briefly explain how PostgreSQL releases work and what is the difference between minor and major releases. I will talk about and give you some pros and cons around the upgrade options. I will give a quick introduction to Pglogical because it's the tool I'll use for the upgrade. And finally, I will show you what are the steps to actually perform the major upgrade. First of all, why upgrade? Probably the most important aspects are the security improvements. Every PostgreSQL version adds modern authentication methods and SSL TLS version support. More features. Also, every version gives us new or at least better options for monitoring, high availability, or disaster recovery. More performance. There are versions that improve massively performance. For example, 9.6 with parallel query or version 10 with just-in-time compilation. However, as a rule, every release improves performance without changing anything on the application level. And new SQL standard implementations, functions, and constructs to help developers bring out the best. Now, a quick introduction on how Postgres releases works. Thanks to its continuous release, over the past 30 years, Postgres earned a strong reputation for reliability, feature robustness, and performance. You probably all know that Postgres is enriched with new features once a year, with what is called a major release. And the minor releases, on the other hand, are quarterly and add security or bug fixes. And there are so many. For example, the latest PostgreSQL 12 minor has resolved 4 CVEs and more than 50 bug fixes. Postgres Global Development Group guarantees these minor releases for more or less 5 years for each major version of Postgres. This means that when they reach end of life, after 5 years from the major release, they will no longer have security updates or bug fixes. From this graph, we can see, for example, that we are running out of steam for 9.5, which will receive its last update this February. Minor releases are always compatible with all other minor versions. That is, you can install a 12.5 on a server that only had 12.1. We don't need to update consecutively. However, it is of course highly recommended to apply them as soon as possible when they are released. To do this, you need to shut down Postgres, install the updated packages, and restart Postgres. Simple as that. However, the advice is to have a QA environment and first update and test there. And always check the release notes that will give information on any, if existing, changes that you need to take care while updating. You should start by updating first the standbys, switch over to your applications, and then update the former masters. There is no need for anything else, as simple as that. There are several options for major upgrades instead, and they all have their pros and cons. The dump and restore is suitable for any PostgreSQL versions, but being very slow is not recommended for large databases. PG upgrade is very fast, especially using the link option. However, fast is not zero downtime. Also, you need to recreate all your high availability setup, as the standbys will not be usable with the new version. When our databases are not suited to use these two options, we can use logical replication. This consists in creating a logical replica and waiting for it to synchronize with the master completely. We can even create all physical standbys needed, and they will get all the replication from the primary automatically. One other pro of logical replication is that you can choose what database you want to replicate. With PG upgrade instead, it's all or nothing. It's recommended to monitor the cluster for a couple of days and check that everything is working as expected. When all the checks are green, turn off the old master and redirect the application to the new PostgreSQL instance. With the use of a connection puller, for example PG bouncer, this can be performed in zero downtime. Like for the minor updates, it's advisable to automate the progress process and test it in the QA environment until you are confident with the procedure. Postgres already has a logical replication mechanism built in. It is available from version 10 and it's mainly implemented on Pglogical. I will show you in this presentation the necessary steps to upgrade with Pglogical. However, there are other logical replication methods to do it as well. Please note also that physical replication is not an option because of the incompatibility of the data directory between major versions. Pglogical, I will use Pglogical version 2. There's also version 3, but it's not open source yet. And Pglogical is a fully integrated PostgreSQL extension that does not need triggers or external programs for its operation. It is a valid alternative to physical streaming replication regarding high availability and disaster recovery. It brings more flexibility, such as replicating between different versions, and besides, you can do selective replication. That is, only what you want, it gets replicated. And one important thing related to upgrades is that it can replicate sequences. The state of sequences added to replication set is replicated periodically and not in real time. Dynamic buffer is used for the value being replicated so that the subscribers actually receive future state of the sequence. Pglogical supports any version of PostgreSQL starting from 9.4. So, since there's logical replication inside PostgreSQL, why would one want to use Pglogical? Or why use built-in replication? What are the differences? The built-in replication can be used in specific environments where it's not always possible to install extensions, such as Pglogical, due to strict rules on what can be installed on those servers. So only built-in functions are available. Pglogical, on the other hand, it's much richer in fun features. There will always be features that won't be part of Postgres for a variety of reasons. For example, the community might think that Postgres doesn't need certain features inside the core, or maybe just because they haven't yet been introduced in the latest version. or perhaps some are only required by specific customers. With Pglogical, we can act immediately where needed and have the functionality available for all PostgreSQL versions. Now that I've finished the introduction to basic notions around Postgres and Pglogical, I will show you the steps we need to take to create a logical replica and use it as the new master once the synchronization is complete. In my example, I will upgrade from 9.5 to 13. Let's see what we are missing by using Postgres 9.5, for example. Every major release of Postgres introduces new fixes and innovative features. There is a nice website, y-upgrade.teppich.com, where you can specify the version you are using, and it will give you all the fixes that you are missing. I counted more than 80 CVEs for this case, and as you can see in the photo, there are more than 2,000 fixes. Allow me to list a couple of very important features that are missing, like parallel aggregates, parallel sequential scans, declarative partitioning, Scrum authentication, just-in-time compilation, parallel creation of index, store procedures, reindex concurrently, and so many others. Okay, before diving into explaining the steps and the requirements for our upgrade, I would like to explain some terms I'll use. The node is the information that Postgres has on the database ready to send or receive with Pglogical. Providers and subscribers are the roles that a node can assume. Provider is a node that sends the data. Instead, the subscriber is the one that receives the data. The replication set manages which tables will be replicated and also what actions on those tables. To ensure that the subscriber receives data from the provider, we must specify a subscription and configure the rules of this through the replication sets. I will be using PG95 and PG13 as host names for the source and destination servers respectively. There are some requirements. First of all tables must have the primary key so that Pglogical is able to identify the tuples to be modified on the subscriber. However, as a side note, on tables without the primary key, it's possible to replicate only inserts, but this is not the case for us. We need everything to be replicated for on our upgraded server. Both present data and new changes. We don't want to miss anything. For example, you can use a query like this if every table has a primary key. This query should return 0 rows. If not, please fix it and before going any further. Tables must have the same name on both nodes. The tables must belong to the same schema on both databases, must have the same columns with the same data types. The check constraints, not null constraints, etc., must be the same or at most weaker on the subscriber than the provider. They must be more permissive. However, in our case of online upgrade, we will need to copy all the schema, so this is not really relevant because we need everything there. So I will show you in the next slides how we can do that. Pglogical runs at database level, so global objects such as rows are not copied. The best way to copy them is by dump and restore global objects only. You can do that by using -- global only options with pgdump all. Unlogged and temporary tables will not and cannot be replicated. DDL is not automatically replicated. Managing DDL so that the provider and subscriber databases remain compatible is the responsibility of the user. The replicate DDL command function allows us to execute DDL on the provider and on the subscriber consistently. So you need to install Pglogical on both the old and the new server. And you need to install the correct version for each of everyone. In our case, Postgres 95 Pglogical for the old server and Postgres 13 Pglogical for the new one. Now that we have the packages installed, we need to configure some parameters in the PostgreSQL configuration file on both servers. Shared preload libraries to Pglogical. This statement will cause Postgres to load Pglogical on startup so that you can use the extension. If there are already other values for this configuration, just add Pglogical separating with commas. Logical wall level. We need this to make Postgres write the walls with the necessary information for the logical decoding. Increase the max worker processes. This sets the maximum number of concurrent background processes that the system can support. We need to allow Postgres to create new worker processes to be used by Pglogical. Increase max wall centers. We also need the wall centers that will take care of sending the decoded data to the other node. At least one per node. We can put a slight number there. Increase max replication slots. Pglogical uses replication slots, so we need at least one on the provider node. All these settings need a Postgres restart. Please note also that the Postgres configuration file is not replicated, so you will have to tune your new server accordingly to application benchmarks and tests, which is very important to run before the switchover. In the Postgres authentication file, we must give replication and connection permissions to the user will use, specifying the database correct name or databases if we use more than one. My user is called PGL user, and this user must have replication permissions and must be a super user. It's strongly recommended that you use a PGPass file to manage your passwords. These changes to the PGHPA file needs only a reload. So these were the preliminary steps. Now on both servers in their respective databases, we need to create the extension. After that, we will create the provider and subscriber node by specifying at least a meaningful name in their connection string. This will identify the databases as nodes ready to be used by Pglogical. We now add all the tables and sequences in the default replication set. You can do that per schema. In the example, I'm adding the tables and sequences of the public schema. This means that any subscriber who connects to the default replication set will receive all changes in the public schema. It will synchronize this way all tables and sequences during the initial phase in a single transaction. For very large databases, you can also choose to add the larger tables one at a time by initially not adding them to the default replication set, but adding them to a new replication set after the subscription is created. Let's make the subscriber communicate with the provider now. For this purpose, we have to create a subscription. From the subscriber node, using the create subscription function, we need at least two parameters, subscription name and the provider data source name. We can leave the default values for the other parameters. The only one parameter we need to be careful of is synchronized structure. Well, as I said before, we must have the same tables with the exact definition on both nodes. We can do that manually with a dump and restore using the -- schema only option with pgdump, or let Pglogical do it by setting synchronized structure to true, as this parameter defaults to false. The other parameters are optional, and in our case, a major upgrade, they are irrelevant. The replication sets would be used to manage which data to replicate to the subscriber. But for our case, we need to replicate all the data, so we use the default replication set. With synchronized data, we can decide whether to synchronize all the data already present or to replicate only the changes from this moment on. This one defaults to true, so it's what we need. Forward origins is used to send changes made by other nodes and not just by the provider. That is for cases with multiple providers and subscribers. And apply delay is used to have a replica with certain delay needed, for example, in disaster recovery cases. Now the present data is replicating from the provider to the subscriber. And when the initial synchronization ends, Pglogical will continue to replicate the new changes as well. We can check the subscription status using the show subscription status function. And if the result is initializing, then we are still in the initial phase of copying the data. If we get replicating, then we are already replicating the data in real time. As I already said, Pglogical works at the database level. So we need to repeat all the steps from creating the extension to the creation of the subscription for each database we use and want on the new server. Always test the procedure in QA environment first, and possibly with a similar data set and server capacity to measure the time for synchronization and simulate the cutover. Test it multiple times from scratch in order to practice and master the procedure. This technique allows application developers to have a sandbox on new major Postgres version environment, similar to the production environment, on which they can also perform benchmarks. When all our databases have a subscription and are all with replicating status, we can switch our application. Set up a connection puller to the main database if you are not using it already. Pause the connection pool. Force the synchronization of all sequences with a synchronized sequences function. Switch the configuration of the pool over to the new system and resume the connection pool so it now accesses the new server. And reload. Okay. We can now clean our new database of everything we used to create this replica. We can unsubscribe, delete the Pglogical node, drop the extension, drop the use role, and reset the rows in the configuration and authentication files related to Pglogical that we previously modified. And that's all. Easy, no? So, summing up this presentation, according to our experience at Second Quadrant and now at DB, the use of Pglogical is the preferred way to upgrade the newest PostgreSQL major version. Especially in the physical and virtual machine environments, where a major PostgreSQL upgrade goes along with a major operating system upgrade and most likely hardware upgrade. Don't forget that this approach allows application developers to test and benchmark the new database and reduce the business risk. A one-fits-all solution doesn't exist. This is just one possible way to perform a major upgrade. Always choose the one that adapts better with your context. It might be that logical dump and restore work perfectly fine. In any case, always start simple and improve incrementally based on feedback from tests. So make sure you test first. As I said before, there is also version 3 of Pglogical that was re-architected to support even more functionality than version 2, including it has a replication slot failover support. That means physical standbys can substitute either providers or subscribers. It supports the replica identity full. The limitation that the table must have primary key is gone. It has transparent DDL replication. Pglogical takes care of replicating the DDLs by default. Faster performance, replication to Kafka and RabbitMQ, transparent support for partitioning and repartitioning on the fly, better conflict detection. It can detect and resolve more type of conflicts, and more granular conflict resolution configuration. Does not require a super user to be used for the replication, and provides much more statistics and viewing tree state, including worker errors visible from SQL rather than from the logs. All very useful for monitoring. The same approach can be used to perform major online upgrade in containerized scenarios orchestrated by Kubernetes. Think about upgrading in the future a PostgreSQL 13 database to a PostgreSQL 16 database without any downtime, just by starting a fresh PostgreSQL cluster using logical replication from an existing one. This is what we are currently doing with our cloud-native PostgreSQL operator. Well, that's all for me. Thank you for attending, and we have some minutes for questions, and also you can reach out on social media.
Perfect. Thank you so much. So
Okay.
I am going to pull up our questions. So there's a few different variations of this question, but people are basically stating that they're running a specific version of Postgres, either like 9.4 or 9.3.4. And is there any sort of limitations in terms of using this method to upgrade from like one version to another? There's lots of questions about like they're using a specific version, upgrading to another version. Is there any limitations?
The limitation, there's no limitation, but only that Pglogical is available only from version 9.4. So from 9.4, it's we don't have any limitation. You can upgrade from 9.4 to 13 or anything. 9.4, 9.5, anything. So we can go lower than 9.4, but that's the only limitation.
Okay. Someone else is asking, how many concurrent databases can I migrate using Pglogical?
Well, there's no such limit. I mean, I think Pglogical is limited, hard limited at 1024, something like that. That's a limit that I think it's not in real databases. However, you need to consider your server. So if you have you have a hardware that supports all those replication slots, all the world senders that are working, there's no problem for Pglogical. It can replicate any number of databases.
And then someone else wants to know, for minor upgrades, is this the fastest way? Is the best way always Pglogical?
Well, for minor upgrades, the best option is, like I said, you just install the binaries and you restart Postgres. You don't have to do anything else. So you don't have to use, you don't need to use Pglogical or any other tool, because, and not even pgdump, that is the simplest one, because it already does it transparently. Yeah, only stop Postgres, install binaries, start Postgres. It's simple, and it's always compatible between minor versions.
Okay, let's see. Another question, what happens if the process fails for any reason? What happens to the production database?
Well, if the process fails, then well, I mean, nothing happens to the production database. It will fail to create the replica, and the only thing that we have to monitor and stay and be careful is the replication slot. It depends on when it failed to do the process. So if it created the replication slot, that slot could keep accumulate WAL, and that could be a problem for the production. That could finish this space and everything. But that is if when you are doing this process, you have to monitor it and to see if everything goes well. And if it's not going well, I think the only thing to see is the replication slots on the primary database, on the production database.
There are a few questions coming through comparing Pglogical to streaming replication and Pglogical to other forms of replication. Do you maybe just want to talk about that topic broadly?
Well, like I said, physical replication is not suitable for an online upgrade because it doesn't. It's not compatible between major versions. So it's a different use for online upgrade. You can use logical replication. You can use other types of logical replication. There are all types like Sloan, Longist, or Bucardo. But yeah, there's also if you are on a version that permits it, also the built-in replication method from version 10 only. And yeah, it depends on the use case. Physical replication only physical replication replicates everything, and it's not. You cannot do anything else. You can at most make a copy and then do a PG upgrade on that copy, on that send-by, and and use it later as a master. But it's not meant to be used like that. And Pglogical, you can use it, or logical replication, you can use it as a standby. But yeah, physical replication, you cannot use it for online upgrades.
Okay, let's see what else is coming through. A lot of the questions are really specific to use cases, so we're probably going to have to follow up with some of those after the session. Someone wanted to know if you could use this cross-platform, so Windows to Linux.
Pglogical, well, you can. We create some binaries also for Windows, but it's only meant for Linux mainly. It's only developed mainly for Linux. So if you have the need to replicate to Windows or to a Windows server, you have to contact us probably, and we see if we can help you with that, depending on the case, right?
Okay, so it looks like those are all the questions that we're going to be able to cover live today. As I mentioned, any other questions that we were not able to cover, we'll follow up after the fact with each of you and provide our answers. Also, as a reminder, you'll be receiving a link to the recording of this session, as well as a copy of the slides to the email address that you used to register. And so that will be coming your way later today. So thank you all for joining us, and we hope you have a great rest of your day. Thank you.
Thank you.